Hi guys, welcome back to Cambridge Guru. We were doing further algebra unit, and in that we have already covered the general binomial expansion, and the last video was about introduction of partial fractions. And we did two examples of type 1 partial fraction where the denominator was of the type something upon ax plus b, cx plus d, and likewise ex plus f, means the denominator terms were all linear. Let us do in this video type 2 where the denominators will be of the form ax plus b cx square plus d type. So there is a difference that there is one linear factor of the type ax plus b and second will be cx square, means a quadratic factor, right? And quadratic factor means it may have some real roots, it may have some imaginary roots. We do not consider any real or imaginary type of concept here. So just look at it that it is of the type cx square plus d where there is no x in this. We have one x square term and second term is a constant term d. Okay, so what is the method for writing this type of algebraic expression into sum of some partial fractions? So let us do this. So 2x plus 3, you will write this as, and always that condition will remain always true, that the degree of numerator must be less than degree of denominator. So here the degree of denominator is maximum 3 and of the numerator is 1. So there is no need to divide numerator with the denominator. So we will write this 2x plus 3 over x minus 1 into x square plus 4 is equal to, so you remember the type 1 denominator where if there is a linear factor, so for this linear factor x minus 1, we will write this a upon x minus 1 as we did in type 1. But there is a slight variation in this, that instead of writing b upon x square plus 4, we will introduce x here, right? And there will be some constant also, bx plus c. The reason for this is that if, let us say, if you take the LCM, right, if you do not include this bx plus c and you just take, let us say, let me introduce another color, instead of this bx plus c, you are writing b upon x square plus 4, and for a linear factor we have a upon x minus 1. So whatever constant or whatever the coefficient you are getting for x square will be a. Meaning when you do cross multiplication or when you simplify this, you will get the coefficient of x square as just a, right? A x square, right? But there might be some partial fraction, there might be some terms, right, which you will get, there might be some constant or the coefficient of x square that you will get by multiplying this x with this x, right? So those you can say those conditions or those scenarios or those type of you can say partial fraction, these have also to be included. Okay, so we cannot neglect this x, right, because there can be some terms here which cannot be neglected here, which can give you the value as x square. Okay, so we will introduce this bx plus c. Okay, now we will take the LCM and then separate the coefficient of x square, then x, and then some constant. Okay, so here I have in the LHS 2x plus 3, and in the RHS coefficient of x square will be this a and plus b. Okay, because when you multiply this x minus 1 with this, you will get bx square, right? Then collect the coefficient of x. X will be x square plus 4a, and here will be cx minus b. So it is c minus b, right, and plus one constant which is 4a minus c, right? 4a minus c means multiplying this a with 4 and then this c with this minus 1 is minus c. So 4a minus c, right? Denominators can be cancelled out from both the sides. Now compare the coefficient of x square, as there is no x square here. So what you will get is value of a plus b is 0. This equation will give me that A is minus B or B is minus A, right? Compare the coefficient for x, you will get C minus B is equal to 2. This C minus B is equal to 2 here, right? And then 4A minus C, 4A minus C, this is equal to plus 3, right? Now, let us take this equation C minus B, because I have an equation for A minus C, so I can form this second equation in terms of A and C. So I will use minus A minus B as plus A. So minus B can be written as plus A. So it is actually C plus A is 2, and third equation is 4A minus C is 3. So let us add these two. This will give, adding these two equations will give 5 times A is equal to 5. That means A is 1. And if A is 1, B is minus 1, because A is equal to minus B. And from this, I can get value of C as 2 minus A. So 2 minus 1 is again 1. So value of C is 1. Okay, so you can write this as a sum of partial fraction, that original function was 2x plus 3 upon x minus 1 into x square plus 4. This can be written as with an identity sign, of course. A is 1, so 1 upon x minus 1 plus b is minus 1. So and C is 1. So I will write as 1 minus x. Okay, interchanging C and B just to make the first number in this as positive, right? So it is actually minus x plus 1. So I am just interchanging C with this bx. Okay, upon x square plus 4, right? So this is your type 2. Okay. Now let us do type 3. Right? Type 3 is, there is a slight variation in, if you compare type 1 and type 3, is that there is one linear factor, there is another linear factor, but that linear factor is a square, right? So again, we will, why we are defining this as type 3, because there are different methods to, writing these algebraic fraction into sum of partial fractions. So there are 3 different methods for different kinds of denominator, right? So type 3 is squaring of one linear factor. Okay, so what is the method? Let us do. Solution is that you will write this as x plus 1 upon x minus 1 into x minus 2 square can be written as first part will remain same. Why same? Because a upon something linear factor, so there is no addition of x or any other constant for this a. You will just write a corresponding to x minus 1 denominator. Okay. Then since this x minus 2 is a linear factor, we will use b upon x minus 2. This is again similar to type 1, but again we have to introduce another constant c to incorporate the terms which can give you x minus 2 whole square, right? Because if you take the LCM, let us say, let us look into the reasoning of this, that why we are introducing b upon x minus 2 and then c upon x minus 2 whole square, right? So isn't c upon x minus 2 whole square sufficient to incorporate all the possibilities? Answer is no. The reason is that if you take the LCM of x minus 1 and x minus 2 whole square, you will get x minus 1 and x minus 2 whole square, right? Within that, and if you take the LCM of this x minus 2, x minus 1 and x minus 2 whole square, again the LCM will be same, which is x minus 1 into x minus 2 whole square. So there is one possibility that you may get one fraction which includes this linear factor x minus 2 without squaring. Okay, so this also needs to be incorporated. So type 1 was a upon x minus 1, b upon x minus 2 without any squaring of any term or any variable. Type 2 was that there is a square of the single variable like c x square plus d. There was not a whole square for the linear factor, right? And lastly, we have the squaring of a linear factor. So for that, we will write a upon x minus 1, excuse me, b upon x minus 2 and c upon x minus 2 whole square. Okay, now the process will remain same. that if you take the LCM of all these three, you will get x minus 1 and x minus 2 whole square, right? So a will be multiplied by x minus 2 whole square. B will be multiplied by here x minus 1 and x minus 2, because x minus 2 is included here, right? And lastly, C will be multiplied by just x minus 1. And in the denominator, we have x minus 1, x minus 2 whole square that can be cancelled from LHS. So you will get LHS as just x plus 1 is equal to this, right? Now, let us combine the coefficient of x square. So here I will get x square, which is a. Here I will get x square, which is b. So coefficient of x square is a plus b, right? If there is a problem in doing this in your mind, you may open this x minus 2 whole square by applying the formula of a minus b whole square and then collect the coefficient of x square and x and constant and so on. So here x square coefficient is a plus b. Then look for coefficient for x. Here I will get x as minus 4x and then a, right? Here I will get x as minus x and minus 2x is minus 3bx, and then here it is plus c. So writing this as plus outside, I will write as c. Here I will get minus 4a and here I will get minus 3b. Okay, and then collecting the constants. So constant here I will get plus 4a, this is plus 2b, and this is minus c, right? And in LHS we have x plus 1. Now just compare these, you will get slightly complicated equations. Since there is no x square term in LHS, it is a good thing. Why good thing? Because equation number 1, which is a plus b, is equal to 0. So there is no need to solve this. You can just replace minus b with plus a or a with minus b, right? This is your equation number 1. Second equation is that c minus 4a minus 3b, this is equal to 1. Why 1? Because coefficient of x in LHS is 1. So this is 1. Now here only you just form equation in either a or b. So let us replace this minus b with a, right? So you will get this as c minus 4a, and here it is minus b is plus a, so you will get as plus 3a equal to 1. That means this is c minus again a is equal to 1. This is your equation number 2, right? And lastly we have 4a plus 2b minus c is equal to again 1, using value of b as minus a. So 4a minus 2a minus c is 1. That means equation 3 is 2a minus c is equal to again 1. This is your equation number 3. Now solving 2 and 3, how we can solve 2 and 3? Just add these two. If I add these two, c and minus c will get cancelled. 2a minus a is a, and 1 plus 1 is 2. So value of a is 2. If a is 2, value of c is 3, because c is 1 plus a from equation number 2. So value of c is 3, and then value of a will be minus b, right? Value of b is minus a. So b is minus 2. Okay, so this is how you will get the partial fraction. Original function was x plus 1 upon x minus 1 into x minus 2 whole square, can be written as 2 upon x minus 1, then minus 2 upon x minus 2, and 3 upon x minus 2 whole square. Okay, so this is how you can write any sum as a sum of partial fraction. Okay, I hope that both the topics in this unit, further algebra, are clear to you. Please mention in the comments if you want any topic to be covered especially, right? If you have any doubt in the previous units that I have uploaded the video of in my channel, Cambridge Guru, so just go through the topics, because I have already uploaded chapter number 1, which is algebra. Second was log and modulus, log and exponential function, and third was trigonometry, differentiation, integration, numerical solution, and now this is further algebra. Please follow my Telegram channel also, because one assignment and all the videos of chapter 1 are also uploaded on my Telegram channel with the same name, which is Cambridge Group. Okay, and I'm trying to upload the link of that Telegram channel in this comment section, and I'm also trying to upload some assignments based on each unit, and you will get the hard copy, not the hard copy, but the PDF of each assignment on the Telegram. Okay, so please follow my Telegram channel also, right? So till then, let us take let me take your leave, and we will meet again very soon with some new unit. Till then, bye bye, take care, see you.